Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, let's have a look at the 2016 question because that was on Modulus, or part A of it. Part B, like I've said here, was on simultaneous equations. So I'm not going to do that here. I'm just going to concentrate on the modulus part. So part A said, find a range of values of x for which the modulus of x minus 4 is greater than or equal to 2, where x is an element of R. Okay, so not alone is it a modulus one, it's also got the inequality sign in it. Okay, so it's a mix. Okay, so I have the modulus of x minus 4 being greater than or equal to 2. Okay, so the first way I'm going to show you is squaring both sides. Okay, so square both sides. So that I'll get x minus 4 squared being greater than or equal to 2 squared. And you can see that once you square both sides, you've got rid of this modulus. Why is that? Because remember, the modulus means the answer could have been plus or minus. When you square something, you make it positive for sure. Okay, so regardless of whether the number was 2, 2 squared is 4, but if it was minus 2 squared is also 4. Okay, so that's what the modulus means. It could be plus or minus, but once you square something, you force it to be plus. Okay, and in maths, it's perfectly okay to do something to one side of an equation as long as you do it to the other. Okay, so that's why it's perfectly okay to square both sides. So that is x minus 4 by x minus 4 is greater than or equal to 2 squared is 4. Or you can square the first, which is x squared, square the second, so minus 4 will become plus 16, or it's twice the product of the two. And you get twice the product because it's minus 4x here and a minus 4x here. So it's minus 8x greater than or equal to 4. Bring everything to one side because you can see the quadratic popping out of that. So you get 8 or x squared minus 8x plus 12 being greater than or equal to 0. So again, solve that. It's the factors of plus 12 that's going to give me minus 8. Okay, so plus 12 and plus 1, or minus 12 and minus 1, because remember, minus and minus will give me the plus. 4 3s, 6 2s. 6 2s is going to work. So I need a minus 8. So the ones that add to give me that middle number, that minus 8, is minus 6 and minus 2. Okay, when it's just a simple x squared, so not like the previous example I did, but when it's just a simple x squared, you can just go straight for the two brackets. Factors of 12. So I'm getting x is equal to 6 and x is equal to 2. Okay, and if you remember from previous work, we call them critical values. Okay, because if I come over here and I draw the graph, like such, my critical values, or the roots of my equation, or where this curve cuts through the x-axis, happens at 2 and 6. Okay, I look up at my quadratic to see what type of a quadratic is it. In other words, is it a smiley face or a sad face? I see that this is a smiley face. So I do it like this. Okay, I don't know how far it comes down. I don't know how steep these are in a way, but I just know that they pass through the x-axis at the roots or at the values that you solve. Okay, so the question asked basically when was the modulus of x minus 4 greater than or equal to 2? We've rewritten that in a different way. So this is still the same equation, it's just written in a different format. Okay, we've squared it, we've brought everything to one side. But really it's the same equation. So I can ask that in another way. I can say, where is the quadratic greater than or equal to 0? Okay. And just like we did before, sorry, get a better color down here. Anywhere down here is the less than 0 line. Okay, remember we call this our 0 line. Okay, and anywhere above it, so you're greater than 0. Okay, so you're talking about the y-axis when you're talking about 0. So y is equal to 0 here. All the y values are greater than 0 up here in this half of the graph, and all the y values are less than 0. If I could do a less than sign right. Okay, less than 0. All the values of y are less than 0 in the bottom half of the graph. Okay, so where is this graph greater than or equal to 0? Well, it's up here. Okay, it's anywhere up here. Okay, so then you say, well, where is that graph greater than 0? So you come back to your particular function and you go, it's here. Okay, this is where this graph is greater than 0. Okay, and then you describe it in maths language. So to describe this part of the graph that has x values that are less than or equal to 2. Okay, that's how I describe this area. Okay, all of the x values will have a value less than or equal to 2. In other words, if I take any point on this function and this function goes on forever, I can map down to an x value and I'll know that it'll be less than or equal to 2. In the same way, how do I describe these x values? Well, these are any x value that's greater than or equal to 6. Okay, again, you could do like a construction line from any point of this curve back to your x-axis, and you will know that it has to have a value greater than 6. Okay, so that's why 2 and 6 are your critical values, because they dictate kind of like the gates of your answer. So your answer to this one then are when x is less than or equal to 2 and when x is greater than or equal to 6. And you can write that as all one inequality if you wish, or you can write it like that. Okay, so that's the answer to that one. Of course, you could have used method 2 where you let, just change to a different color, maybe purple. The modulus of x minus 4 is greater than or equal to 2. You could have said x minus 4 is greater than or equal to 2, or x minus 4 is greater than or equal to minus 2. Okay, bring this over. X is greater than or equal to 2 minus 4. X is greater than or equal to 2. Or x is greater than or equal to minus 2 minus 4. X is greater than or equal to minus 6. Oh, because he should be a plus. Minus 2 plus 4 is again plus 2. And I got all my signs wrong. Right, let me redo that. Spot the one who was up watching the toy show last night. Okay, x is greater than or equal to 2 plus 4. X is greater than or equal to 6. Okay, bring this one over. X is greater than or equal to minus 2 plus 4. X is greater than or equal to 2. Okay, so you will get your critical values in that way too, and then you have to figure out the graph as well. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.